Hello everyone, happy to see you here, welcome back to my channel. Today we have a great cubic equation b cubed minus b squared equal to 18. We need to solve this equation for b, so right now let's start. First of all, let's write this 18 on the left side, okay? Let's do it. So this is our first step. We just write b cubed minus b squared, and this 18 let's write on the left side. So we have minus 18 is equal to 0. Right now, let's scan what we have in the beginning. We have b cubed and b squared, so we have a difference, b cubed and b squared. Right now, let's try to express this 18, but just keep in mind that we need to find our cubes and a square. So that's why my quick recommendation is to express this 18 as 27 minus 9. Okay, let's do this. Let's express this 27 minus 9. A lot of students might be asking, why 27 minus 9? Just wait a few seconds. First of all, let's do it. So b cubed minus b squared minus, instead of this 18, we write 27 minus 9. So we have 27 minus 9 equal to 0. And right now, our last step, let's open our parentheses. So we have b cubed minus b squared minus 27 and plus 9. And a lot of students might be asking, why do you choose these 27 and 9? Why not like 24 minus 6 or are there different expression? That's why 27 can be written as 3 cubed and 9 can be written as 3 square. So that's why we can group our cubes and our squares together. So let's see. B cubed, we have in the beginning b cubed minus b square minus 3 cubed and plus 3 square. And right now let's look at this question from from another perspective. So we have b cubed right here, so we have cube and 3 cubed, so we can group it. We have b square and we have 3 square right here. We can also group it. Okay, right now let's do it. First of all, we have in first parenthesis difference of cubes, b cubed minus 3 cubed. So b cubed minus 3 cubed in another parenthesis we have minus b square minus 3 square. Yeah, we have b square minus 3 square. So I really hope you understand this solution until this moment. What we're going to do next? Right now, let's scan what do we have in first parenthesis. In first parenthesis, we have difference of 2 cubes. In this parenthesis, we have difference of 2 squares. So let's remember this formula from school, okay? Let's do it. So the first formula, let's remember a cubed minus b cubed. So difference of 2 cubes. So a cubed minus b cubed equal to a minus b. Yeah, so we have a minus b. And in another parenthesis, we have a square plus ab and plus b square. And right now, difference of squares right here on the bottom, difference of squares. So a square, maybe difference of square. This is all known formula. Everyone knows about this formula. So a minus b, and we have a plus b. So right now let's expand this expression in terms of this formula. So this is our difference of cubes right here, and this one on the bottom is difference of squares. So right now let's apply it from a new line. First of all, I'm gonna apply a difference of 2 cubes. Let's do it. So we have b minus 3, we have b square plus 3b and plus 9. And right now, difference of squares. So we have minus b minus 3 and b plus 3 equal to 0. Okay, and right now let's look at this question from a different perspective, from another angle. We have b minus 3 right here, and we have b minus 3 at this place. Right now, we can easily factor this b minus 3 as a common. So let's do it right now. So b minus 3. We're gonna factor it, b minus 3, and in another parenthesis, what do we have? This expression, b squared plus 3b plus 9. So b squared plus 3b and plus 9 minus what do we have? B plus 3 from here, so b plus 3 equal to 0. Okay, and right now let's simplify this expression because we can't simplify this b minus 3, so we can actually rewrite it, b minus 3. And in this parenthesis, we can simplify this a little bit. We can actually get rid of this first parenthesis. So we have b squared plus 3b and plus 9 minus b and minus 3. And right now, let's find the common things. We have 3b and b. We have 9 and we have 3. So we can actually simplify this a little bit. So we have b minus 3 in the beginning, b minus 3 in the beginning, and in another parenthesis we have b squared, so the same beginning, plus 3b minus b plus 2b, and 9 minus 3 plus 6 equal to 0. So we have a product of two parentheses, and a product of two parentheses equal to 0 when the first parenthesis is equal to 0, so in our case b minus 3 is equal to 0, so this is our first branch, b minus 3 is equal to 0, or the second parenthesis is equal to 0, this parenthesis, so b squared plus 2b and plus 6 equal to 0. So we have two branches, linear function and a quadratic function. So we need to solve these two equations right here. Of course, maybe you can write or doesn't matter. Teacher will understand these notes. Okay, b minus 3 equal to 0. From here I would b first, because this is a linear function, we can easily solve this instantly. So b first is equal to 3. What about this quadratic equation? We can also solve it with the basic method. Of course, this is up to you. How do you prefer solving this one? I'm going to choose this basic method of coefficients. So a equal to 1, b equal to 2, and c equal to 6. Okay, so right now let's solve this question in terms of this basic method of coefficient, in terms of this method with discriminant. So we have b second and b third equal to minus b, so we have minus 2, or let's write our full formula. We have minus b plus minus square root of discriminant, so b squared minus 4ac, and all over to a. Let's plug in each of these elements into this spot. Okay, let's do it. First of all, we can plug in minus b, so minus 2 plus minus square root of b squared minus 4ac, b squared, so we have 2 square minus 4 times 1 times 6, and all over 2 times a, 2 times 1. Okay, let's simplify this real quick. So we have minus 2, let's rewrite it, minus 2 plus minus, what do we have right here, 4 minus 24 equal to minus 20, so square root of minus 20, and all over 2 times 1 we have 2. Okay, so this is our roots, these are our two complex roots, but we can simplify this a little bit, because this square root of minus 20 we can rewrite. So let's do it. We have minus 2 plus minus, we can rewrite this square root of minus 20 as 4 times 5 and times minus 1, and all over we have 2. Okay, and right now we can split it, because there's like a really important property, our square root property. So plus minus square root of 4 times square root of 5 and times square root of minus 1. All over, right here we have 2. Square root of 4 equal to 2. This is our imaginary unit, this is our I. So that's why we can write the next. We can write minus 2 plus minus 2 square root of 5 times I, or let's write 2i square root of 5 in our numerator. In our denominator we have only 2. And the final step, maybe you're interested in this because a lot of students prefer splitting this expression by real part and imaginary part. That's why we can write it as minus 2 over 2 plus minus 2i square root of 5 over 2, and right now we can cancel these two, and these two, and our answer minus 1 plus minus I square root of 5, minus 1 plus minus I square root of 5. So these are our two complex roots. So let's gather all the roots together. So we have b first equal to 3 and b second and third equal to this expression. So let's gather all the roots together. Let's write, for example, on the left side right here, so our answer, so b first equal to 3 and b second and third equal to minus 1 plus minus I square root of 5. Two complex roots right here, one real number root right here, so everything is great. And right now in the end, let's check real quick our real number root. Let's rewrite our equation from the beginning. So we have b cubed minus b squared equal to 18. Okay, and let's plug in, for example, for b equal to 3. Let's check our real number root. So we have 3 cubed minus 3 squared equal to 18. Everything is great. Our root is absolutely correct, because right here we have 27 minus 9 and equal to 18. Everything is great, so our root is absolutely correct. But I'm going to say a few really important hints, few really interesting tricks, because a lot of students might be thinking, okay, let's solve this question by inspection, for example. Yeah, we have right here when we plug in b equal to 1, b equal to 2, b equal to 3, and they say, okay, b equal to 3 is a correct expression. So that's why a lot of students might be solving this question by inspection, and this is not a good method. Maybe when you don't have enough time, for example, on your exam, this is a good method to write something. But if you want to solve this question completely, first of all, you need to know about fundamental theorem of algebra. You don't have to write it, you just need to keep it in your head, because when you have this type of expression, our cubic equation, every time you have this, doesn't matter, like cubic equation, fifth power, 10th power polynomial, every time just scan what is the highest power, because for example right here, b cube, the highest power is 3, so it means that we will have 3 roots in total, and this is our proof. We have these 3 roots, we found it, we found our three roots. But if we are talking about quadratic equation, for example, right here we have the highest power is 2, so it means that we have 2 roots in total, and we solve it. A linear function, 1 is the highest power, so it means one root. So this is extremely important theorem, and I really hope you understand my logic. 3 roots, 2 roots, 1 root. And that's why if you have a time on your exam and you have cubic equation, it means that you should write 3 roots. First real number root or 2 complex, or doesn't matter, it can be like 3 real roots, I don't know exactly, there are a lot of equations, maybe 1 complex, 2 real, or 3 complex, a lot of combinations. And just be careful, because you can lose your points on your exam because of this. And if you have a time, just learn this, for example, equation right here. This is not a hard equation, very basic. I can say that this is a hard equation because very basic steps. This is like tricky moment. Secondly, 2 formulas from school, difference of cubes, difference of squares, and in the end, basic calculations and linear equation and a quadratic equation. So not a hard way to solve this equation. So I really hope you understand my solution. Of course, write your notes, write your assumption, write your comments on the bottom of the video. So in the comments below, in the comment section, it will be really interesting to exchange information. What do you think about this equation? Because there are a lot of really interesting moments right here. For example, when you see this equation, you can easily, see that b equal to 3 is a root, so then you can combine, you can express this b squared, for example, as minus 3b plus 2b, something like that. You can express this 18, and you can factor b minus 3 in a different way. So of course, if you're interested in another approach, you can also do this, because this is maybe a tricky moment, this is maybe a tricky approach, but there are a lot of different approaches. So if you're interested in this, you can do a quick investigation or with you and with your teacher. It's also really great. So thank you everyone for your time. Take care of yourself. I really hope you understand it. If you still have any question, if you have a problem with the basic math, with preparation for Math Olympiad, you can also visit my YouTube channel. I have a lot of like 600 videos, and I really hope this video is helpful for you. And it's also really great when you learn something new. Maybe not a lot, but sometimes a lot. It depends on yourself. So it's also really great to see you respond. And if you learn something, I'm becoming extremely happy. It's also really great that my video is helpful for students, for teachers all over the world. Yeah. So wish all the best in life. Take care of yourself. Have a great day. Also, write your thoughts, write your response in the comments below. It's extremely kind of you when you leave your response. What do you think about this video? What do you think about this question in general? Because there are a lot of teachers, a lot of students here. We have a really big community, and it's also really great that we are all together here. And yeah, this is my thoughts about it, and I really want you to say thank you for everything. So wish all the best in life. Take care of yourself. Have a great day. See you in the next videos.